In this video, we will be looking at real-world applications and interpreting graphs. By the end of the lesson, you will be able to investigate and analyze functions and their characteristics graphically, including domain and range, intercepts, and zeros. Let's take a look at situation number 1. Larry made a scatter plot showing the apparent height of a football at 1-second intervals during the time period the ball was in the air. So let's take a look at this graph. So Larry, who we're assuming is about 6 feet tall, throws the ball in the air and somebody else about the same height catches it. So we're looking at this happening over a period of time. So let's first, we have time here, label our axes. So here we have our x-axis, and our height is sitting on our y-axis. If we recall back to our earlier lesson, our x-axis is always our independent variable, and my y-axis is always my dependent variable. My independent variable and my dependent variable. So now let's answer some questions based on this graph. What are the lowest and highest values in the domain? So let's recall back, our domain is our x. So here is my domain. So let's look at the lowest value and highest value in the domain. So my lowest value here, we start at 0 seconds and we go over here. Now we see we have 4 and 5. So in between here would be about 4.5. This line here. So this point here would fall at 5.5. So my lowest value in the domain would be at 0 seconds. And my highest value in the domain would be about 5.5 seconds. That's how long it took for the ball to be in the air and come back. Number 2 says, what are the lowest and highest values in the range? Again, my range is my y values. So I'm going to look at my lowest value in the range and my highest value in the range, which looks to be about this point. So I'm going to come over here, and that's at about 13. And let's label here. So I have 6. My lowest value is 6 feet. And my highest value is 13 feet. Those are the lowest and highest values in the range. Let's look at number 3. Does the scatter plot represent a function? Why or why not? So if we remember how to test if a graph is a function, we do our vertical line test. So if I were to draw a vertical line through any points on this graph, I only hit one point. So is it a function? Yes. Why? Because it passes the vertical line test. But also, the ball is only at one height at each point in time. That's what this means in the context of our problem. The ball is only at one height at each point in time. So for 1 second, I only have one height. For 3 seconds, I only have one height. So that makes it a function. Number 4, at what height is the ball at time 0? So we go to time 0 on my graph, and I look at the height. My ball is at 6 feet at time 0. And now what is this called? What would I call that? It's something that we talked about in one of our earlier lessons. When my domain or my x value is 0, what my y value is, that is the y-intercept. We have this point sitting on the y-axis. It's on the y-axis. That's called my y-intercept. Let's take a look at a few more. How long is the ball increasing in height? How long? So when we look at our questions, it's asking for how long. So our answer should be in seconds. I'm looking for time. So how long is the ball increasing? Remember, increasing means going up in height. So I'm looking at the height and I want to know how long it's increasing. So I start here. My ball, when it was thrown, I'm increasing till about here, and then you can notice it starts decreasing. The ball is now coming down. So from here to here, my ball is increasing. So how much time has passed? From 0 seconds when I threw it all the way over here till 3 seconds. So the ball is increasing for 3 seconds. Let's look at number 6. Again, the question is asking about how long, so my answer should be in seconds. How long is the ball in the air? Okay. Now we're looking at the whole graph. How long is the ball in the air? From the time it was thrown all the way to the time somebody caught it, from 0 to, remember we talked about this was at 5.5. So the ball is in the air the entire time, or 5.5 seconds. At what time, number 7 we'll look at what time is the ball 9 feet high? So again, at what time, where again our answer should be in seconds, because that's what our question's asking us. At what time is the ball 9 feet high? So I want to find 9 feet. About here, here's 8 and 10. 9 is just in the middle. So there's 9 feet. But again, I come over, I see I have another 9 feet. So the ball is actually at 9 feet twice. It hits it first when the ball is thrown, and then as it's coming down, it returns to 9 feet. So we're actually going to have 2 answers here. So it's 9 feet. I come down at 1 second. It's at 9 feet again at 5 seconds. So I have 2 answers for that. It hits 9 feet twice. Let's look at number 8. At what time is the ball at its maximum height? So remember, maximum is from increasing to decreasing. So at what time does my graph change from increasing to decreasing? And that would be just about here at 3 seconds. Number 9, what is the maximum height of the ball? So we have the time here when it hit maximum height, but what is the actual maximum height? So at the 3 seconds, when it changed, because it was asking for time, the actual height is at 13 feet. And lastly, does this scatter plot have any zeros? Why or why not? Well, let's recall that zeros are the same thing as the x-intercept. We talked about before that the y-intercept was when we hit the y-axis, when we crossed or touched the y-axis. So if we have any x-intercepts, that should be if my graph crosses or touches this x-axis. And we can see that it does not. So this scatter plot does not have any x-intercepts. The graph does not cross or touch the x-axis. In the context of our problem, this means the ball does not hit the ground. Okay, let's take a look at some common phrasing you may see in some of the questions when you're looking at graphs. Okay, these are some verbs that could be used to describe changes commonly seen on graphs. So the first one is go up. Okay, if it's asking about going up, common words you could see are rise, climb, or increase. We saw increase in this example we looked at today. If we're asking about going down, we could see the words decline, drop, or decrease. Those all mean that the graph is going down. The question could also ask about the graph going up and down. And a word you may see there is fluctuate. Fluctuate. That means the graph is going up and down. If the question asks about reaching the highest level, that's your maximum. And if it's reaching the lowest point, that is the minimum. These are just some common phrases you may see. It's not an entire list of what you may see. As we do some more examples in class, you may see some other examples. You may see some other words that we will use in describing graphs. This is the end of the video portion. Bring your notes to class and we will continue to look at more examples together.